Now, before we get started, it's always good practice to have a read of the API documentation. So in our giant list of course-related links, you'll find a link to developer.apple.com/documentation/create_ML. And this will tell you how Create ML works and how you can use it for computer vision, natural language, and a whole bunch of fun stuff that we can do. And once you're done, then we're going to get started applying this and learning about how to use it. So first, before we train anything, we have to give our model some data in order to teach it what a dog looks like, what a cat looks like, and what a rabbit looks like. So for that, we're going to head over to images.google.com and we're just going to search for dog. And now we have a whole bunch of images that any human would be able to recognize is a dog, even though some of them look a little bit weird. And we're going to head over to our desktop and we're going to create a new folder. And I'm going to call this training data. And inside training data, I'm going to create another folder called dog. Now, the label that you give to this folder is incredibly important because this is the label that the machine learning model will associate with every single image or every single piece of data you place into this folder. So that means that when in the future you give it an image and it's an image of a dog, it will give you back this label that is the name of this folder. So depending on how you want your data to come back, you can have it as lowercase dog, or you could have it as a dog, or whatever you want. But in our case, let's just create it like so. Now, inside this folder, I'm going to place various images of dogs. So I'm just going to have my Finder with my dog folder on the left and my Google Images of dogs on the right. And I'm going to have them side by side because this will make it really easy to just drag and drop images without having to go through a process of right click, save as, dragging and dropping it. So what Google Images allows us to do is to identify an image, click, drag, and place it into our dog folder. And so we're going to look at all of the images that are of typical dogs, not so much of the weird dogs like dogs with glasses, because it might just confuse our model. You wouldn't teach a child that this is a dog, so we're going to try and keep it to classical images of dogs. So that looks like a dog, that looks like a dog. This is you using your own human intelligence to identify all the images that would satisfy the label dog. And as you're going through this, obviously the more data that you provide your model, the more data that you give it, the more accurate it will become. So I'm going to keep it to maybe just 10 or 20 images in this case. But if you find in the future when you're training your own models that it's not very accurate, and we'll talk about accuracy and how to determine it later on, but if you find that it's not very accurate, it's usually because you haven't given it enough images to work with. But for our purposes, this is probably enough because we're asking it to distinguish between cat, dog, and rabbit. And those things look very different from each other. So the more similar the images you're trying to differentiate from, so for example, if you're trying to get your image recognition model to be able to know the difference between, say, a Labrador and a pug, then you will need a lot more images because they actually look quite similar. But if the classification is more broad, say the difference between a cat and a dog, then you won't require as much data. And that's the general rule. So now that I've got all of these images of my dogs for training, the next thing I need to do is I need to create another data set that is going to be called the testing data. And this folder is again going to contain a subfolder with the same label of dog. And inside here, I need to place some images that I haven't yet shown my machine learning model. So I'm not going to have any of the same images that I put into my training data. And I need to scroll down and find some new images of dogs to show my model, because this testing data set is going to be used to validate the accuracy of our machine learning model. Because they are labeled, then the machine learning model can check what it thinks it is and then looks at the right answer and evaluates how accurate it was in the process of classifying it. So we're just going to scroll a little bit further down and we're going to drag on some new images of different dogs for our machine learning model to try and test itself. And usually the classic ratio between training dataset and testing dataset is about 80 to 20. So if you had about 20 images for training, then you only need about 4 or 5 images for testing. So let's try and find some non-weird looking dogs and use it for testing our model. Okay, so I've got 5 images now and I'm happy with that. Now I'm going to go through the same process and I'm going to repeat it for the other animals that I want to teach my model. So I'm going to have one that is cat, and I'm also going to have one called rabbit. And we're going to repeat the exact same process. And of course, inside our testing dataset, we'll also need to have our folders for the images that are cats and also rabbits. And we're going to again find 5 or 6 images to test and evaluate the accuracy of our model. Now, it's really important when you're doing this that the labels that you give to the folders inside the testing data match the ones that you gave inside the training data. So you can see over here, I've got dog, cat, and rabbit singular. If over here I decide to put dog, cat, and rabbits plural, then it will confuse our model because it'll view this as a different label for a different item. So make sure that you spelt it exactly the same way, including capitalization and all of that. And then just go ahead and add the testing data for your other animals. All right, so I've completed that process and I've now got testing data as well as training data for all 3 animals. And roughly I've got about 20 images in each of the folders for the training dataset and about 5 images for each of the folders in the testing dataset. So for anyone who's ever worked with machine learning and training their own models, then you will know just how much data you normally require just performing a very simple image recognition task. And the reason why we're able to save ourselves so much time and hassle and pain of having to collect and clean and classify and label all of these pieces of data is because the Create ML framework leverages the existing artificial intelligence that Apple has been building for their Photos application, as well as their Siri framework. And we're able to build on top of that and essentially stand on the shoulders of giants, and in the process saving us lots and lots of time and making this model creation process far easier. You'll also notice that when we include images for our cat or dog or rabbit, I've been pretty non-discriminate about these images. I haven't been checking, for example, what is the format of this image? Is it a JPEG? Is it a PNG? What is the size of the image? And again, if you've worked with machine learning before, you'll notice that they tend to have stringent requirements in terms of the sizes of images. Often they need to be the same size, same dimensions, they need to be the same format, whereas again, Create ML framework takes care of all of that for us, and it doesn't actually matter what size or dimensions the images we use in our training and testing data sets. And as long as you're using the standard formats for images, that's JPEG or PNG, then it will work just fine. And also, you notice that all these images are individually named something kind of random, like download 3 or image 5. And it doesn't matter the actual name of the image that you've got in here. As long as they're all inside the folder that has the label that you want, then you're pretty much good to go. So as you can see, that was a pretty pain-free process. And we're going to go and move on. So now, And we now have all of the data that we need to train our model.